Okay. Good afternoon.
Good afternoon,
Good
Mr.
Good afternoon, Mr.
Good afternoon, Mr.
Yes. Okay, I'm fine. Do you remember what you have seen in our previous lesson? Do you remember what you have seen in our previous lesson?
About potential energy and how to calculate potential
Okay.
energy.
Okay.
Potential
Okay.
energy. About potential
Okay.
energy.
Okay. We have seen in our previous time about potential energy. Potential energy is the energy of a body due to its position from the Earth's surface. Okay. So potential energy of a body depend on its height and its mass. Potential energy is equal to mass times gravitational acceleration times what? Height. So in our today discussion, we are going to see conservation and transformation of mechanical energy. We will see this one, or we will focus on this one. Okay. That means energy is converted or transformed from one form to another. Okay. Sorry. Therefore, we are going to see how the energies become converted from one form to another. For example, potential energy can be converted into kinetic energy. Kinetic energy converted into potential energy. For example, when you throw at upward vertically at upward ball, first it do have only kinetic energy. When it reach on a certain height, it is kinetic energy become or converted into potential energy. When it reach on the maximum height, it do have only potential energy. Okay, it do have potential energy. We will see in our today discussion conversion and the transformation of mechanical energy. Okay, therefore, transformation and the conversion of mechanical energy is needed to enable people, machines, computer, and the other devices to do work. Okay, to do work. For example, this one is instead of compass, let us see computer. For example, when energy is transformed, it's needed or enable people, machines, computer, and other devices to do work. So, transformation and conservation of energy is essential for us. Essential for us. The other one form of energy can be changed into other form of energy. As I have said, for example, in your stove, electric energy change into what energy? Heat energy. And in flashlights, electrical energy and chemical energy change into light energy and heat energy. Okay, into heat energy. Therefore, it is essential for what? For people. Okay, it is essential for people. Therefore, one form of energy can be changed into another form of energy. So we can do this one transformation and then conservation of energy. Okay, let us see some example of transformation of energy. When a ball is thrown upward vertically, kinetic energy is converted into potential energy, and then instead of electrical energy converted into heat energy. In flashlights, chemical energy and electrical energy converted into light and heat energy. In this case, for example, in both cases, kinetic energy and the potential energy change one to the other, but their sum their sum means their mechanical energy is conserved. Okay, it is constant. That means mechanical energy is equal to potential energy
Plus
plus kinetic energy. Therefore, when kinetic energy change into potential energy change into kinetic energy, but the summation of potential energy and the kinetic energy are constant. That means it is mechanical energy is constant. Okay, it is mechanical energy is constant. For example, if you throw this ball upward If you throw this ball upward, take this one is as ground, This one is take as ball, okay? Take as ball. At this point, it do have only potential energy, okay? Potential energy. Only the potential energy is equal to mechanical energy, okay? It is mechanical energy. And it is kinetic energy is equal to what? 0. Because of what? Why? For example, if you take this ball
There
at
is no
this
moving.
point, yeah, because of what? There is no
No move.
motion, or it is speed is equal to 0, okay?
Zero.
It is speed is equal to 0.
Zero.
When it reach, for example, let us assume this one is A point, this one is B point. When it reach at point B, it is potential energy. It do
Convert
have
to
potential energy.
convert to kinetic energy.
Yeah, sum of potential energy here changed into kinetic energy, which is equal to potential energy plus kinetic energy gives for you
Mechanical energy.
mechanical
energy.
energy. For example, at a point, if at a point, potential energy is equal to, for example, assume potential energy is equal to 15 Newton. Assume at B point, if the potential energy become 10 Newton, what about this kinetic energy? What about this kinetic energy of this ball? Assume at the first, the potential energy was 15 Newton. When it reach on B, it is potential energy become 10 Newton. What about this kinetic energy? Huh? 5 Newton. 5 Newton, okay? Because of what? Because of sum of potential energy changed into kinetic energy, okay? Kinetic energy. Therefore, it is mechanical energy gives for you again 15 Newton, okay? 15 Newton. When it reach or as it strikes the ground, it do have only kinetic energy, okay? It do have only kinetic energy, which is equal to, it is mechanical energy. What about it is potential energy? What about its potential energy when it hits the ground? It
Zero.
becomes 0. Because of what? Why?
Because because the motion in because everything stops or
Stop.
the ball cannot. The ball there is no stored energy.
Okay, okay. As it strikes the ground, there is no what? There is no what?
Stored energy.
There is no height. The height becomes 0, okay? The height becomes 0. How do you see? The potential energy here or at this A point totally changed into kinetic energy. Therefore, energy can be converted from one form to another, okay? From one form to another. Therefore, potential energy can be changed into kinetic energy can be changed into potential energy in this case. Again, you know, for example, in case of another example, pendulum motion. Pendulum motion. You know pendulum. What is pendulum means? The pop of this pendulum maybe or comes here and again comes to here. Therefore, the motion of this pendulum, there is some conversion of energy or change of energy, okay? There is some change of energy. For example, let us say A, B, and C. At this point, this pop or this pendulum will have only potential energy, okay? Only potential energy, which is equal to this mechanical energy. Here it is kinetic energy is equal to 0 because of it is at rest. At this point, it become what? At rest. There is no speed. There is no speed. Between this one, it do have both kinetic energy plus potential energy, okay? Both potential energy plus kinetic energy. Both potential energy plus kinetic energy. Again, at the B point or at this point, it do have only kinetic energy, okay? It do have only kinetic energy, which is equal to this mechanical energy. What about at C point? Again, it do have only potential energy, okay? It do have only potential energy. And between B and the C, between B and the C, it do have kinetic energy plus potential energy, which is equal to it is mechanical energy, okay? It is mechanical energy. Have you understand this concept, the conversion and the transformation of energy? In
Yes.
case of the motion of pendulum and the motion of the throwing ball at upward, the throwing ball at upward, because of it is height and it is speed, you can decide it at what point the kinetic energy is maximum, at what point the potential energy is maximum. You can understand from this one, okay? You can understand from this one. Therefore, this one is some of the conversion and the transformation of especially mechanical energy, okay? Especially mechanical energy, especially mechanical energy. Have you understand?
Yes.
Have you understand
Yes.
what you have seen?
Yes.
Okay,
Yeah.
let us see, let
Yes,
us see
Mr. Yes.
another point, laws of conservation of energy, okay? Laws of conservation of energy. For example, there are, for example, Newton's law of motion, magnetic law. Again, there is laws of conservation of energy, okay? Laws of conservation of energy is one of the fundamental laws in physics, one of the fundamental laws in physics. Do you know what is laws of conservation of energy states that? Do you know?
Energy is neither created nor destroyed.
Yes, energy is,
Neither created nor destroyed.
yeah. Laws of energy states that energy is neither created nor destroyed. It's only transformed from one form to another form, okay? That means uh, energy can be everywhere, change from one form to another. That means energy is conserved, okay? Energy is conserved. For example, if you take mechanical energy is conserved, but it can be changed into potential energy and
Kinetic energy.
kinetic energy and vice versa, okay? Therefore, laws of conservation of energy state that energy is neither created nor destroyed. It is only transformed from one form to another form, okay? Under this one again, under this one, mechanical energy that a body possesses exists, look, exists as potential energy or kinetic energy or both. For example, at a certain point or place, mechanical energy of a body exists as potential energy or kinetic energy or both. So you can see what we have seen in our above discussion in case of a ball thrown upward, vertically, and the motion of pendulum, okay? The motion of pendulum. Therefore, mechanical energy means potential energy plus kinetic energy. Potential energy plus kinetic energy. Therefore, the mechanical energy of a body process exists as potential energy or kinetic energy. That means mechanical energy is categorized into, as we have seen in our previous time, potential energy and the kinetic energy. Or from this one, mechanical energy is equal to kinetic energy plus potential energy, okay? So if mechanical energy is given for you, you can find the kinetic energy or potential energy. And if potential energy and the kinetic energy is given for you can find the mechanical energy of a body, okay? Mechanical energy of a body. So energy is neither created nor destroyed. It's only everywhere transforming from one form to another. Okay, from one form to another. Sorry, I am hearing additional sound. For example, from Muratam.
Sorry.
Please be stable around of what is around you. Okay. The other one, we are going to see under this one energy of a falling water. Okay, energy of a falling water do have its own energy, especially mechanical energy, and again a wind do have energy. A wind do have energy. For example, if you take a falling water at its first restriction from the main source of hydroelectric energy, if you see for our country, it is the main source of hydroelectric power, okay? Hydroelectric energy or power for our country. Yet we have not used it exhaustively, incorrectly, okay? And the other one, what you must know under this one, when the water reaches the turbine blades, when the water reaches the turbine's blade in hydroelectric power plant, it has only kinetic energy. For example, you know, water from the dam, when it hits the blade of the turbine, it do have only kinetic energy. It do have only kinetic energy. And the water at the intake tower has only potential energy. You know, for example, in dam, when you see the dam, it do have in the intake tower, it do have only potential energy. When it reaches on the turbine blade, it do have what energy? Kinetic energy, which is called it is mechanical energy. And when the water passes, when the water passes through a pipe from the top of the tower, some of this potential energy is converted into kinetic energy. So the mechanical energy becomes the sum of potential energy and the kinetic energy. That means it is mechanical energy is equal to potential energy plus kinetic energy. Okay, kinetic energy. So at what point, for example, a falling water do have potential energy and the kinetic energy, and both kinetic energy and the potential energy. You must understand and you must differentiate. Okay, you must understand and you must differentiate. You must differentiate. Therefore, the falling water do have energy, or what we call mechanical energy. Okay, what we call mechanical energy. Mechanical energy. Do you have understand this one? Do you have
Yes.
understand?
Yes, Mr.
The other point what you must know under this one again, the other point what you must understand, know that the mechanical energy of the water at the dam tower, the dam tower is only potential energy, as we have raised above. In the dam tower, it would have potential energy only, because it is at rest. There is no motion in the dam, therefore it will have potential energy. Then the mechanical energy of the water at the bottom is only kinetic energy at the bottom of the dam. When it hits on the turbine, it will have mechanical energy, what we call, which equal with kinetic energy. Okay, the potential energy above changed into mechanical kinetic energy of the water. The water. Again, wind energy. You know, as wind to have energy. For example, we can construct uh, electric energy from wind energy. Okay, from wind energy by using what? By using windmill. We can produce, or we can generate electric energy from wind energy. Okay, we can generate electric energy from wind energy. For example, again, windmills called wind turbine with two or more than blades mounted on a tall tower can drive an electric generator attached to it. For example, you can see around some cities like at Ethiopia do have, what I know from Adama and the other place, which energy which is produced from wind energy. It is by what method? The windmill or turbine attached to. Please keep silent. Whom you are talking, simply talking, okay? Huh? Sorry, others. For example, when the blade or the turbine, the wind turbine attached to or rotates and connected to or attached to generator, it can be produce what? Electric energy, okay? Electric energy. For example, generator, for example, if you see generator, what is generator? Generator is what? Huh? What is generator? Generator is, huh? Do you know generator?
Yes.
What is that?
Yes.
What is that? A device.
It's
Generate
from gas.
electrical energy from wind
Okay.
or
A
water.
device
I don't know.
which converts mechanical energy to electrical energy. Okay, electrical energy. Generator is a device which convert or change mechanical energy to electrical energy. For example,
Electrical energy.
the wind turbine, when it rotates, it is what? Mechanical energy or electrical energy? When it rotates, it is mechanical energy or electrical energy. The rotation of wind turbine. When you see, it is mechanical energy or kinetic energy. So when it attached to, when it attached to generator, that mechanical energy is converted into electrical energy. Okay, electrical energy. This done when the wind with kinetic energy rotates the blade. Okay, you see everywhere this one on media, for example. You can see by your own or naked eye, as well as you can see on the media when the wind rotates the blades of the wind turbine. Okay, the blades of the wind turbine. Hence, the rotated windmill causes the generator to rotate and produce electric current. For example, in generator, when the generator rotates again, it produces electric current. That means generator is a machine or a device that converts mechanical energy to electrical energy. Okay, mechanical energy to electrical energy. Therefore, in our today concept, you must know what's the transformation, the concept of transformation and the conservation of energy, how it can be converted from one form to another, and the laws of conservation of energy, energy of falling water, and energy of or wind energy. Okay, wind energy. If you know or if you understand some concepts from this one, you can understand conservation and the transformation of energy. Okay, transformation and the conservation of energy. Okay, have you understand what we have seen still now?
Yes.
I hope you have understand
Yes.
what you have seen still now.
Yes.
Let us give for you few questions which is the concept of conservation of the transformation of energy. Okay, let us see some questions.
Your screen is not visible for me.
Yes. Which
Your
one?
screen is not visible for me.
Not visible?
It is.
Is it?
It is mistake.
Okay, let us try. Let us try.
I can't see any of the notes.
You can't see the screen now?
Can.
All of you or one of you?
We can't.
Yes,
ይታያል ወይስ
mister.
አይታይም?
I can see, mister. I can see.
ይታያል አይደል
I
ሚስተር?
can see you.
ኦኬ ኦኬ
ይታያል።
Tired. እኔ ይታየኛል።
ዌይት
ይታያል ሚስተር። ኧረ ይታያል።
ይታያል።
ማለት ያውቃል ለእናንተ ቪዚብል
ይታያል።
ግን ለእኔ አይታየኝም።
እሺ what about now?
ኮኔክሽን
ይታያል።
አዎ
ስክሪኑ
ይታያል
አይታይም?
ሚስተር።
አሁን
ለእኔ ግን ሚስተር
ይታያል ወይስ
እየመጣ አይደለም
አይታይም?
ስቲል።
ሚስተር ኢንዲቪዥዋል ፕሮብሌም ነው። ለእኛ ይታያል።
አዎ
እንደ እንትንሽ ነው፣ እንደ ኔትወርክ ኮኔክሽን።
ችግር ነው ሚስተር ከኢንተርኔቱ።
የኔትወርክ ኮኔክሽን ይሆናል።
ሳይለንት ones.
ዋይፋይ አጠገብ ነኝ።
what about now?
ይታያል ሚስተር።
አሁንስ ይታያል ወይስ አይታይም?
ይታያል።
ይታያል ሚስተር።
ታየ።
ስቲል እየታየኝ አይደለም።
ይታያል ሚስተር። ኔትወርክሽን
ኦኬ ኦኬ wait so
ሚስተር
let
ሲጀምር
us start
ማለት ነው
question
ስክሪን
together,
ታይቶኝ
okay?
ነበረ። ከዛ በኋላ ግን ኦቱ ጋር ስገባ አልታየኝም።
ይታያል እኮ በደንብ።
እኮ try to check
Sorry,
try
is
to
that
check
how?
the connection between you, okay? Try to check. Let us see this question. Let us see this question. Question number 1, for example, which one of the following is correct about the energy conservation or conversion by heat engine? Okay, look, by heat engine. Mechanical energy to electrical energy, chemical energy to mechanical energy, electrical energy to mechanical energy, mechanical energy to electrical energy, okay? Chemical energy, okay? Do you know heat engine? Heat engine. So, which one of the following is correct about this one? Which one is correct about heat engine from the given choice? Which one is the answer? Try. Which one is the answer? Which one is the answer? Determine. Determine one of it.
C.
C, one. What
D.
about the others? C.
D.
What about the others? Yes.
D.
Okay. D.
D.
Okay, let us see together. Heat engines change chemical energy to mechanical energy or mechanical energy to electrical energy. Okay, therefore it change the electrical chemical energy to mechanical energy. Okay, the question number two. A body is drawn vertically upward. If it is mechanical energy is conserved, then which one of the following is true? Okay, which one of the following is true? Look, a body is drawn upward vertically, like what we have seen in our above discussion about the ball drawn upward. Okay, upward. If it is mechanical energy is conserved, then which one of the following is true? A.
B.
Okay, wait me. A. Kinetic energy is constant. B. Potential energy is constant. C. Mechanical energy is constant. D. Mechanical energy is zero. A body is drawn upward vertically. Okay.
A.
Kinetic energy is constant. Okay, what others?
Potential energy is constant.
Potential energy is constant. Okay, what about others?
Mechanic energy is constant.
Okay.
C.
The answer is what? The answer is C. Mechanical energy is constant. Because of what? For example, when you throw upward anybody, after it reach on a certain age, for example, as you throw upward a body, it is potential energy increases. Okay, this potential increases, and it is kinetic energy become decreases. And after it reach maximum height, it come back down. Okay, it come back down. So it is kinetic energy is again not constant. It is potential energy is not constant again, but it is mechanical energy is constant, okay? Mechanical energy is constant. That means, for example, if at the first, this kinetic energy is 10 Newton, 10 joule, and then it is potential energy when it reach on maximum, it become 10 joule, okay? 10 joule. In above discussion, we have written the units of potential energy and the kinetic energy by joule. It is not by Newton, it is by joule, okay? By joule. Recorrect it. So the answer is what? The answer is C, okay? It is mechanical energies
Is constant.
Yeah, this constant. Again, question number 3. Which one of the following conversion takes place in hydroelectric power station? Look,
C.
which one of the following is
D.
with me? Chemical energy to electrical energy to chemical energy, mechanical energy to electrical energy to mechanical energy.
C.
The answer is what?
C, Mister.
T.
Mister.
C.
Mechanical energy to electric energy.
Okay, let us see the end equation. A body is released from a certain height above the ground, okay? Released from a certain height. If the air resistance is neglected or omitted, then it is potential energies increases. It is mechanical energies the same. It is kinetic energies decreases. It is potential energies constant. Huh? For example, when a body released from a certain height, it is potential energies increases. This one is correct or wrong? No, it is potential energies decreases. It is kinetic energies decreases. No, it is kinetic energies increases. It is potential energies constant. No, it is potential energy is decreases or changed into kinetic energy. Therefore, the answer is it is mechanical energies remain the same. There is no change. In case of mechanical energy, it is what? Conserved, okay? Conserved. So under this such type of transformation and conservation of energy, you must know such type of question, okay? Such type of question. So I will stop our today's discussion on this point. Next spread, we will see about power, okay? We will see about power. Refer some written materials, or if you do have textbook, refer your textbook about power, and then we will see next spread about power, okay?
Okay.
For today, enough for us.
Okay.
See you next
Oh,
time.
so-
Goodbye, okay?
Bye.
Bye, Mister.
Bye.
Bye.
Bye. Bye.
Bye.
Bye, Mister.
Bye. Bye.